Okay, so welcome back again to the fourth video, okay, or second meeting. Any questions? No, no. Okay, just raise your head or whatever hand. Okay, so I have a couple of notes here that I still thought I'll show you. Let me share the screen. So a couple of things that I wanted to show. One of them is just a command line on Git. So there are a lot of other things that we'll see later on in the course as we go along. But here I have one thing. Okay, so there is the git config file in your home directory. Okay, so this is /.gitconfig. That's the general configuration file. Here, this is the basic configuration that you need to have. Your name and your email. So this is going to be in every commit message. And then you can also add various aliases. So far I was trying to use the full commands because to show it that way. But actually I have these shorthands for various of the aliases for various of the commands. So for example, I would just type git st instead of git status. Okay, so and this is what you have. So this is not a shell level configuration or shell level alias, it's Git specific. And there are a couple of interesting ones. And one of them that I don't know, inherited from somewhere is the git lg, which shows the commits in a more compact way, where you can, this is the short version of the SHA, and then each commit message and who committed and so on. So especially when you have a long commit history, so for example, let's go to, where is it? As I told you, I don't know. Git OS, let's go here, okay? So there are a couple of projects that I cloned here earlier, Perl data alias, let's say, git lg, okay? So this is some CPAN module. And you can see the history and who committed and when and so on. Okay, so it's git log with a couple of flags, basically. So if you look at the git config, you can see that this is basically git lg. And I can share it, and you can find various places, various of these things. Okay, it can be very, very useful to have these git configurations. That's one thing. The other thing is, and we can stay in this repository. You can say git show and one of the commits, and you don't even need the full SHA. You can have this short version of the SHA, and it will show you the exact change in that commit. So it's a git diff between the specific commit and the previous one. So this is the change that is in that commit, okay? And you can also work this way. So git head is always the topmost commit that where you are at now. And this is the last commit that was in here. But you can also work with tilde and then give a number, and this how many steps back you look at. So if you look at the commits as a single chain of things, which you can, more or less, then it will go back in history and show you that specific commit. So sometimes you would say, okay, I would like to see what is the previous commit. And then you can look at that and so on. Okay. With git show and this way. Git. No, I wanted to go back to our own repository, which is CM. Where is this CM? Oh, it's here. Okay. So if I make some changes here, docs index and let's say I replace this one, and I can say git diff, and it shows what changes I made locally. Okay, and actually, something that I nearly never use, I recently learned it, and for that I need to cheat because I don't even remember. I added some aliases for that. So there is this git diff w and diff one, two things. So I can say git diff one, I think, and then it will highlight the specific character that was changed, which is very useful if you have a long string and it says, okay, this line changed, and then you don't see where, because you have two long strings and one character on 37th character changed from L to 1, okay? And you can never see, we'll never see this, but these flags can help. So there are a couple of these really nice ones. So this was this git diff -- color words equal dot, and the other one is color words, which I think it means just it's a, I don't know what is this dot, but if you say color words, it would per word show you which word changed, which is also nice. So if I just I type W, I think that was the alias, so it shows you the specific word that changed. Okay, and it can be also useful when you have words in your text. Anyway, that's good. And then let me go back again to where I was earlier. Git OS and some of the projects here. Perl data alias. And I wanted to show you something else. It's called git blame. And that's do it on the README file. So what it does, it shows you all the lines of the current file. So this is the current file. And this one, it's not an exciting file. Let's try to find another one. Lib data alias. Okay, git blame. So now you can see, and here neither of this one is very interesting. Oh, the same author everywhere. Okay. Anyway, what you would see here is that you see all the lines of the file, and here you see the exact commit, the SHA of the exact commit, where that line was last changed and by whom. So it's a very easy way to find, okay, if this line changed, and you say, okay, you find a bug in some line, and then you try to figure out why was this bug, why is this here? Okay, because, well, obviously no one wanted to add a bug, but someone made that change. And then you can find who made the change when, and then you can say, okay, so now let's look at that specific commit, okay, to try to understand what's the story there, okay, and then you will have the explanation, okay, because obviously the person wanted to do something good, okay, or at least that's our assumption, okay, and then you will see that, okay, that person wanted to do something, and as a side effect, or I don't know, typo, whatever, introduced this issue. And that can be really powerful and useful to understand why something happened. And if you go back to the website, and GitHub, well, actually in the other browser would be easier. GitHub here, Flask. This is a Python project, but I know that it's relatively active. And then you go to I don't know whatever source Flask. I guess I go to this one, and then I can click on blame here too. Yeah, and then really you can see each line was changed by a different person, because it's a very active project by many contributors. So along the line, okay, sometimes 6 months ago, last year, or whatever, 11 years ago, something changed. So for some reason that line was changed, okay, and then you can really see what's going on. Of course, these are the import statements, so that's the less interesting part. But if you go into the deeper in the code, let's see if I can get there. So all the import statements are less interesting. Here is like documentation, pieces of documentation, and somewhere there's also code in this thing. Okay, so deprecate config attributes, whatever. Okay, so that's super useful, I think. In the good old Subversion word, I think I don't think that it works here anymore. But you could also say praise. Nah, Git doesn't do that anymore. Okay, so Subversion had the same command or two commands for the exact same thing. So some people use Git Subversion blame and some use praise for the same thing. You can alias it, so you can have an alias to praise, and then it's more positive attitude. Okay, what else? Nothing for now. Okay, one more thing I can show. Git k all. So where is it? Okay, here it is. So it's written actually in Perl TK. In TK. I'm not sure. I don't think it's using Perl. It's using TK, and it's a GUI for looking at the history of this. It's not really nice, but can be useful. I don't know. I can't grab it now. But here maybe. Here, okay, yeah, okay. So now you can see, you can click on it, and then you can see the content of the commit, and when was it changed, and so on. And it can be especially useful if you have branches, because on the command line it's a little more difficult to look at branches and how they interconnected. Okay. So this comes with, and just to note, this is git k one word and minus all. And there are some other flags, but I've never used them. So the only other flag I use is the minus all, and then it keeps telling me that it doesn't work. Okay, so it's just a typo I make. Okay, remember it's -- all. Anyway, so what I wanted to do now is actually try to get you to discuss some project that we would like to do. So first of all, one of basically the assignment will be to create your own web page. But some of you, I mean, Darren already did it, I think, while you were talking.
I only did a one-liner, but I will embellish it.
You can create more markdown files, and you can look at other projects, of course, how what they use. You can do tons of things, basically, really interesting things.
And I can add the theme, and I can do my SSH keys and do it all via the command line. So that's all fine.
Okay, and one more thing, actually, let me show this one. So what you know is that we have this website, okay, OSDC, okay, .codemaven.com, okay. So this comes from a repository which is called GitHub OSDC CodeMaven, and repositories. And so that site is coming from this repository, okay, because the same username .github.io. So that's the main page. And if you look at it, you will see it has a docs directory and has some static files. Some markdown files, actually. These are HTMLs are just, these are just files because I moved some pages, so I kept some HTML file to redirect the other ones. Okay, but basically this is the announcement of our course. This is the page that you can see where I announced the course. Okay, that if you go to the OSDC website and then you look for C/OSDC Perl, this basically is generated from that page. Okay. But we also have the other page, which without the C, which is just this, which is generated from our own repository. So the nice part is that if you have your own username, which let's say in my case is C, which in this project's case is OSDC code Maven, and then it has the repository OSDC code Maven github.io, and that's the main page. But any repository you have in this account, and in our case, the repository name is, let me go there, Git OSDC. So the repository name is OSDC and Perl. So this is the name of the repository. So if this repository generates a GitHub page, it will be a folder under, it will look like a folder under that main page. So this repository, and so you can have multiple repositories. The main page is always the one that is called username.github.io. But underneath, you can have separate projects generate their own page, and they will be just subfolders in the UI. So if we come here, so this is the same as the name of the repository, and the content is generated. That's totally separate. Okay. So okay, I wasn't sure what to do. Let's do this one. So we have a repository here, CM demo. Okay, and now we're going to, and it's still git status, git diff. Oh, okay, so I don't want this change. Okay, last thing to show. I don't want this change. So I say git checkout docs index, and it resets my latest change, most recent change. So the changes I had in my working directory. So if I look at now git status, nothing is changed. So it removed all the changes I had here, basically. Okay, so I made some change and now it reset it. That's one of the uses of git checkout. What I would like to show you now is this other thing, where we have the CM demo GitHub UI, but now I'm going to change this. So instead of the pages, so instead of using, where is it? Instead of saying that just deploy from a branch, okay, that we had earlier, so we create some static files and it will generate some other static files. Instead of that, I say use GitHub Actions. Okay, so now it's going to be the first time we are using GitHub Actions on our own. So now it says, okay, you're using GitHub Actions, and then it has the static HTML, which I haven't tried. I think it's basically the same as we have earlier. No, no, this could be used, I think, to what I have in Perl Weekly. So I already generated the HTMLs, and I'm just asking GitHub to display them. But that's not the interesting part. This is the interesting part. And for now, I start with Jekyll. Okay, this is what would be the default, but I'm starting it with here. So I say, okay, configure this one. So now it will create a file in my repository in the .github folder. It will create another folder called workflows. So these are two new folders it's going to create. And inside it's creating a YAML file, which can be either YML or YAML, doesn't matter, I think. And the name doesn't matter either, it's just gives you the default. And it has some stuff in there. So let's start the commit. And there are tons of other things, obviously, it can do, but this is going to commit this file directly to the main branch. Everything is fine. So what GitHub Actions does actually is that every time okay, let's start with this. Every time you push out a new version of your code, it will run whatever is written in this action, execute whatever is written there. Now that whatever is written there can be in a regular application running the tests. Okay, in this case, it will generate a web page. Okay, but
there will be lots of questions there about where does it run it. I understand how it can just take the very basic web page we've just done and and compile it into HTML and get it ready and prepare a page. But I don't understand how that's going to go on and do testing and stuff for us. So that will
Okay.
be.
So what you get here is that GitHub basically have what they call runners. It's basically a virtual box. I think actually, yeah. So it's basically they're starting a virtual box for a virtual machine for you, whatever it's called. It's a virtual private server, okay, or a Docker image or whatever. So something that you can, a server. They start you a server, and then you in that server you can run whatever code you like. Basically, that's what they do. And then at the end, they shut it down.
Okay. And they do all this hundreds of times for no money.
Yes, yes.
All right.
Okay. Because they're so nice and they are Microsoft. No, that's actually, so yeah, they do it. I mean, they have some limits. Okay. I think for open source stuff, they don't have a limit now. You know, once they killed all the other competition, they might start to introduce limits, but maybe not. I don't know. For private repositories, you have a limit of, I think, 2,000 minutes of this run per month in your free account. If you would like to have more, you pay. Okay, so basically that's the deal, and I guess for corporations, 2,000 minutes is very, very quickly is gone. Okay, so that's what you get. Now this was executed. Let's see what happens here. So now we are back to 0 because now it's not using those files in the doc folder. Okay, it's using the file from the README, from the main folder, because this is the default. But let's go and see what's going on there. So now I'm going to pull this. So pulling is basically two operations. Is GitHub fetch, so that would copy all the changes that were made in the GitHub repository to the local repository. So git fetch is the opposite of git push. But git fetch would just bring it here. It wouldn't be part of your main branch. You still have to do something because you made some. So your branch, your main branch, made some progress, and in the GitHub there was also some progress. Okay, so in this case, why would be there a progress? Either this, what I just did, that I went there and it made a commit there, or because you accepted the pull request. Okay, some other worked. Or if you're working with a couple of people on the same repository and everyone has rights to push, then while you were sleeping or working on your computer, someone else made some changes and pulled them out. So right now, before I pull it, let me make some changes here. So I make some changes to the docs index. Okay, git add, git CI. So this is just the areas for commit, the CI for me. Okay, so I made some changes here. First of all, what if I want to push it out now? I can't, okay? Because there are some changes that were made outside, which are not here locally. And you have to somehow merge them together. Somehow, okay, wrong word. You somehow have to integrate them together. So some person made some changes and it's on the GitHub repository, in the remote repository, and you made some changes or I made some changes here locally. And somewhere these need to be integrated. Now, GitHub says, if you push it out, then it's GitHub that needs to do the integration. And GitHub doesn't understand the word, okay, basically, from your code. So the only way you can integrate them is that if you're pulling down, fetching all the changes that were in GitHub, locally you do the integration, and then you're fine. Okay, so it actually, I think it over explains it, that it rejected because the remote contains work that you do not have locally. So what I need to do is now fetch the remote repository and then integrate together. But because it's such a common task to do, Git has this command for it, git pull, that does the fetch and the integration. And I use the word integration because there are two possibilities how to integrate things. One of them is called merging, and the other one is called rebasing. Okay, so if you merge, I don't know if you can see me, so I stop the because if I'm going to draw, then no one will understand it. So basically what happens is that there's a common point. Some people I made some changes locally, and there are some changes that were made outside, and when it's fetched, it looks like this. So we diverged. Some here, some changes here, some changes here. So how can we combine them? We can merge them together. It's a diamond form. Okay, that's one way to integrate these changes. The other way to integrate is to say, okay, let's pretend that my local changes actually happened after all the changes that were made outside. And we take all of my changes and push it at the top of the remote changes. This is called rebasing. Okay, the result is that the end result is that now basically it looks like a straight line. So instead of having this diamond, that okay, some people work here, some people work here, and then we are combining them. Instead of that, we will pretend that it just happened one after the other. Okay, many people prefer. I personally prefer this one, the rebase version. Okay. Questions here?
Yeah, I guess I just don't quite see how that to me implies there's going to be loads of testing required, because you can't just trust what that's going to do, can you? Because you've both gone off on your diamonds and done your own testing, and then that might not be a valid combination.
Exactly, right. That's totally right. I mean, in the old days, okay, in the old version control systems, basically the idea was that you lock your file, no one else can change it until you free your lock. That was quite actually bad. The reason it was bad because there were a lot of cases when you were working on the top of the file, I was working on the bottom of the. I would want to work on the bottom of the file. We don't interact. Why not work at the same time? But what really happened is that some person logged it because wanted to work on it, and then went on vacation for 2 weeks, and then no one could work. So you had to break these locks, and it happened quite often. And it turns out that if the project, and you are right, you need a lot of testing for this. If the project is well managed, then you will actually work in different areas. Different programmers will work in different files. Okay, so you won't have that many of these integration issues. Obviously, that's usually not the case, but still, the better it's managed, the less of these issues you have. And the other thing is that you need to have automated tests that can easily verify that any change you make is not breaking the previous ones. And that's where what comes in the automated tests and continuous integration. So basically, you do it so quickly one after the other that the changes are so small that if something is broke, then you can immediately get feedback. So the big problem is actually when I start working on some feature for 3 weeks, no one knows about my feature. In the meantime, someone else works 3 weeks on his feature, okay? And then now we try to merge them together and nothing works because, I mean, lots of things were changed. But if every day we push outward changes and try to integrate, then these there are more frequently we'll have these conflict things, but they will be much smaller. So resolving them will be much easier. And if you do it once an hour, or I mean frequently, it's no rule for doing it once an hour or half frequently. If you do it frequently, then the amount of problems is going to be really, really small. Of course, if you have 100 people working on one single file, well, there we have the management program, right? So, so that's basically there, right? And these combination things or integration things can actually, there are two main possibilities. One is that you worked at the top of the file, I worked at the bottom of the file, nothing is interacting there. Git can combine them automatically, no problem. The other, it still might be that they don't work together, right? Because maybe I changed the definition of a function and you added the use of that function with the old definition. So it still can happen. And that's what I need to here do the combination, run my tests, and then push it out. Okay, so but it can also happen that we change the same line. Okay, now this is obviously means that okay, something is fishy here. Okay, in the design, right? That you decided that this default value needs to be 5, and I decided it needs to be 6. So someone has to decide what is at the end, right? So you have to look at that. But in general, in most programs, you have these automatic combinations or integration, and that usually just works fine. Okay. More questions here?
Yeah, I mean, it's hard to know where to begin, really. We have well, there's several. I mean, we work in our own, and normally people work on their own code, you know, set of code, and normally that kind of situation where two people working on the same set of code, it doesn't happen very often, except in one or two places. So one place in particular is we have we've been talking about changing the way it works for a long time, but at the moment for database updates we have a big program that says set up all the fields on the system, add in bits of data as needed, and then the data is set up for an empty system to start with. And so consequently, we normally add at the bottom of this thing, and now I want you to add this column to this table, or whatever it is. And one of the problems is that, at least that we're using Mercurial, as I said once before, and a lot of this depends on the quality of the merging, because what Mercurial will do is say, I add a function at the bottom, somebody else adds a function at the bottom, so we both added something completely separate at the bottom. And the code just doesn't know what to do. I mean, the merging almost randomly does the wrong things. It's really hard to, I mean, we can, we have different workarounds we can do to try to stop it from happening, but it's often goes wrong in the merge.
So in Git, I don't know if the merging system is better or not. But in Git in general, if there are overlapping changes, then Git will just show you, okay, these are the changes from here, this end, and this is from that end.
Absolutely. I mean, that's exactly what.
Then
it's very, very similar. I mean, if you use Mercurial, you wouldn't see any difference. It looks almost identical. I've heard comments that the quality of the merging is better in Git, but I've yet to see that in action.
I don't know. No, I'm saying I have no idea. I haven't used Mercurial.
No, either. But so I think there are places where almost inevitably there's stuff in common that is really, really hard to deal with, because just like this big configuration file or whatever it is, not configuration file, but big setup file, and people are always changing it and always changing it at the same place just because it's always at the bottom. I wasn't certain what you were saying about the merging either, as opposed to the rebase. I mean, I totally get rebase.
I wanted to
And,
show it. I'm not sure. Yeah. Okay.
I totally get the rebase, and I've used that in a different context. And it's clear that if I'm working away on a branch, somebody else has done some work, maybe that's sort of been committed and pulled into the main thing. I want to be able to say, I want to pretend that I've started to work now. All the changes I've made are on, you know, the current good version, current master, or whatever it's called, main branch, and that is clearly a good thing. But if you're doing a merge, which happens sometimes, again, it's, you know, which one wins really. Which, I mean, that's the problem with Mercurial. Sometimes you make a merge and you do it, quotes, the wrong way, so it somehow undoes everything if you don't do it in the right order.
Yeah.
And so if you've got these two sets of parallel changes, I add a function here, somebody has a function here, and suddenly it can see this function's here, but it's missing from here. Maybe it thinks, oh, I have to delete it, and or I duplicate something, because now I've added a function here, somebody's added a function here, and now it says, oh, I've got this third function here, and it's a different place, and all sorts of stuff like, I mean, that happens on a fairly regular basis,
Yeah.
and it can be quite hard to stop.
Yeah, I'm sure. I mean, I'm sure it happens in Git as well. I mean,
Yeah.
The more you work and the more closely you work, in more similar areas of the code you work, the more likely you will have problems.
Yeah,
Right?
absolutely. Yeah.
So regarding that common shared configuration file, so that's I think this is the exact same problem when you have one central library that everyone is using, and therefore everyone is changing. So here we have a configuration file, and
well, I didn't mean config file was the wrong word, but I mean, it's sort of,
okay.
But you're right. What you said was correct. It's a big module that everybody's using. Yeah.
Yeah, but if it's a config file, so it's a config file or it's a big module?
It's a big module that kind of creates the configuration. If that makes any sense. So it's
But
basically,
people change the code.
yeah, people change the code. They don't change. I mean, it's not like a set of SQL statements. It's a set of
So it's
the program that generates the SQL.
It might be that the best thing to improve the velocity basically is to split that file up.
Yeah,
So
yeah. I mean, I think that's
I was thinking about just configuration. I would say, okay, just split it up into separate files in a directory, in a folder, and then just the system will just read all of them. Like, okay, like in many cases in Linux, you have either a single central configuration file or a folder where the system reads all of them and then just doesn't care.
Yeah, no. I mean, I think we've been thinking we know that we must change it, because it's getting, it started, it took 5-6 years ago, or longer ago, it's nearly 10 years ago it started. It was fairly small and manageable, but 10 years later, it's massive and unmanageable. And we keep looking at it and going, yeah, we really need to do something about this.
Yeah, okay. So one of the things that when I used to have this just Git course or subversion course, the first slide was usually that, okay, just because you have version control doesn't mean that you can stop talking to other developers.
Yeah, absolutely.
So it won't solve the problems. Okay, you'll still have to talk to each other. That's so. Do we have some more time? I mean, we have 10 more minutes, because I would like to, if you have questions, I will happy to try to answer. If not, I continue with
let's make progress.
Okay. So I'll get back to this. So I wanted to show here, now I'm going to use git k all and remind myself to put two dashes there. So this is what I have here, like, okay. So I made this, the remote, it thinks that the remote is at this point. Obviously, we know that the remote has moved forward, and then we have these changes. So what I do now is I type in git fetch. So this is, okay, I can't do this because I'm running this code here. So I'm moving it to the background. Okay, so I run git fetch. So what it does, it brings all the changes from the remote repository locally. And if I go to this place, then and I refresh it, I think I can have this update. So now we can see that it has this split. Okay, the main, what I changed locally is here, and the remote main is has this Jekyll file that was added. So there's still no integration. Locally, you can see that there is some kind of separation here. So what happens if, and now I need to change here something. I am not even sure, I don't know how to do this otherwise. Okay, so because I set my default strategy of pool to be rebase, and I would like to show you the default strategy, which is merging. So if I actually call git pool here, what it does is actually it first runs git fetch, but it's not doesn't do anything anymore now because we have already fetched, and then does a git merge. So what? Oh, it wants me to I have to explicitly say this now, apparently. Okay. So on all time there was a default. Now I have to say explicitly rebase false. Right? This was the error, git config, rebase, okay. So this command would update what I just did in the file. Okay, either setting the rebase false or rebase to true. So I run git pull and hopefully now it will work. Okay, so now it says, okay, I have these two sites. I have to merge them together and I need some explanation here. It's going to be a new commit, so please explain. And here I can give some explanation or I can just quit. And it will use that first line as the explanation. So now if I go back to my view here and update, well, you know what? I'll keep it, I put it aside for now. Git K and open a separate one. So we have all of them. We can see all of them. So you can see this is what I had earlier, and now this diamond shape or sort of diamond shape happened. Okay, this is a new commit that includes both changes. Yeah, so this is what commit looks.
Perhaps I'm confused with the sequence. I understand what's happened, but I kind of expected it to do the merge and then sort of offer you, do you agree with these things before you then commit the resultant stuff? But it seems like it's doing the merge.
It's doing the merge automatically because it can. It only if there were real conflicts when you change the same rows or very close rows, then it will say, okay, there is some conflict, I don't know what to do. Do it manually. And then it will show you, it will create a file, basically. Well, we can see it later, but it will create a file where we have both content. Okay, these lines are coming from here, these lines are coming from here. And then go ahead and you decide what to do. Okay, but if it can, if the changes are, I mean, now I changed one file here, another file there. So the default behavior, obviously, it doesn't mean that the code works. Okay, as we said, that it can be that in one file I changed the signature of the function, and in the other file I added the use of that function, the old signature. Right?
Yeah, I guess there's a slightly different way of thinking, because normally I would do my code change. If I was on my single strand, I would do my code changes, then I would test them, and only after I'd tested them would I then do the commit. So I guess it's just asking you. You could actually what you can, so you can do a lot of things here. Okay, so this is just like sort of the default behavior, but you could create a branch, merge there, try there, and then go back, bring back everything to your main branch. And you don't have to ruin your main branch. Okay.
you can do it in all kind of ways. This is just the default behavior. That's one of the powers and of course dangers of Git, that you can do anything. And now I'm going to show the scary part. Okay, so that's what we have here. So I said, okay, but I would like to show you the rebase thing as well. So how can I show you the rebase? Well, I git reset head tilde 1. Okay, this will remove the most recent commit, which was the merging, right? And I even say it hard, so it will disappear from the local working directory. Otherwise, it would keep it there. So now it removed the most recent commit. This is very destructive, okay? Just remember, if you do this, your most recent commit is gone. Any change, it's gone. You can't restore it. It's not saved anywhere. So if
right, so that this is good. That gets rid of the most recent commit, and then the other thing, the checkout, gets rid of the stuff you've changed but not committed yet.
Yes.
Yeah. Right.
Yeah.
Good. They're two very useful commands. I often throw away what I've done.
Okay, but if I start it again, this one, so we are back to the point where we have this split thing, right? I remove the merging, and now where is this editor? Here it is. I go back and say false, true. So I say that the pooling, the rebase, that I would like the pool to do a rebase when it's instead of a merge. So I run git pool again. Actually, I could have just executed git merge or git rebase, but okay. And it's done. Okay, now it doesn't even ask me questions. It automatically does everything. It doesn't ask me to merge, because what happens is this. This is the result. Okay, let me bring all three of them here. So this is what happens after fetch. You have the changes locally, you have the changes from the remote. If you merge, then this will happen. You create a new commit, integrating the changes from there and from here. And if you say rebase, it pretends that everything remote did happened before anything I did, regardless of the actual timing. And if you are lucky, the result is the same in the merge and the rebase case. So the code result should be basically the same, but it looks different in the history.
I wonder if that's an extra test you could do for every change that's hit multiple people have done, whether you did both types of a merge and a rebase, and the resultant output was identical. Would that give you a warmer and fuzzier feeling that the merge was successful if they were identical outputs? I
don't think that you need to care about that.
Yeah.
Maybe Git even having the source code such tests. I don't know, but I don't think that you need to care about that. What's way more important is that you have enough tests and to have a decent, that you have trust. I mean, it's not just you are going to change the code and the coworkers. You're going to also upgrade a module, a dependency, go on a different operating system because the previous one, I don't know, stopped. It's not supported anymore. I mean, the hardware is gone. Okay, so that's the classic example of why would you want to upgrade your operating system when you have a fine running operating system, but your hardware breaks down. And when you buy a new hardware, the old version of your operating system doesn't run on anymore. Okay, so you have to have a new version of the operating system that comes with a different kernel, different everything. So how can you make sure that your code runs on it? So it's not even that. So even if you don't make any changes yourself, you'll have to at one point, and then not talking about various security patches to the modules you depend on them or whatever. So it's really, really absolutely valuable to have a way to easily and reasonably well verify that you whatever changed didn't break the previous, whatever worked so far. Questions? No? Okay. Shall we keep going on the merging and branching thing? Or do you have any questions here?
No.
Okay. I'm closing these ones. Historical. So now that it's merged, or actually rebased but integrated, I can push them out. And by the way, if you're wondering about these colors and names, well, it's some shell thing that updates my prompt. So git push. Okay. Yeah, so it pushed it out, and now, well, everything is there. And now we can go and look at GitHub workflows Jekyll pages, this file, and we could go over it, but I think we already passed like the 2 hours. So even though I would really like to continue and explain all this, but I guess it will have to do it next week. So I really wanted to show you, I mean, try to start playing with this. Oh, okay, let me just show it quickly. So what here it says basically is, this is the reason that it shows whatever is in the README now. Okay, if I change it and say, okay, the source is the docs folder, okay, and then I commit these changes, git add, and push it out, okay, then in a couple of seconds, the site will be updated with the old content that we had in the docs directory, docs folder. And then this is basically saying, so you can say, it says, run this Jekyll thingy, okay, whatever is in there, and provide these parameters to it. So it says, okay, the source is doc, and this is the destination, and then there is some magic saving that folder and pushing it out as GitHub pages. And we can go over that later next time, and then you can see how OSDC 2000 Perl GitHub workflows. We here also have a file that uses this another thingy. Okay, these are called actions that has some code, and then this is how it deploys to the GitHub pages. So basically, this is what we have in order to generate our own small website that uses, and that code, okay, that code is here in this repository, OSDC site generator, and then this is a Python code, doesn't really matter, that reads the stuff and generates the pages. Okay, this is how the pages are generated, or little pages. So let me get back here, and I'm sad it didn't update. I don't know why. Let me get back. Okay, actually here, if you click on the actions, oh, you see, it didn't like something. So our actions failed here. And then I can check why it's failed. So this is the output of each GitHub action. And no such file or directory. Change, dear. Ooh. Why? Disabled, enable incremental. What happened here? With Git. Oh, You didn't say docs. I put it doc, not docs. Okay, so let's see if this happens. This is happy. Now, if I go back in the meantime quickly and I click on the actions, I can see it's this yellowish thing because it's running now. I can even, it's queued actually. Okay, it's not running. Okay, it's still waiting for the thing to run. Okay, but it will run. Well, so these are the runs of this. Well, it's still. Where are you when we need you? GitHub Actions. Oh, you see, it started to run. So it started to run now. Actually, we can follow what it's doing. Coming here. So it's pulling now. And I guess it's done. No, not that. It's running the Jekyll now. And now it's done. Okay, and it's green. So I don't know if it means automatically or it will take still some time, but I think now it's done. So the mistake I made earlier is that I put the folder name doc instead of docs. And now why is it still yellow? Oh, okay. So we are back to having this page with this thing. And of course, there you can put any program. So instead of this, you can write here. Sorry, instead of this, here you could run, instead of this, we could run, any program you write in Perl or any language. Obviously, we need some configuration to have the Perl compiler installed and all of these things. And if you generate the output into this folder called _site, and the rest is there, then it will be a page. So you can write some Perl code that will generate your page. But that's next week. Okay? So the assignment is try to build your own web page, and let's give you another quick assignment that I have with this. I'll put it in the file OSDC public readme request. Basically, actually I can show it here. Mentors subdoc. Okay, so add this field. Okay, projects. I'll add it to our repository. Add the new field to your JSON file, projects, and in there list the repositories, the GitHub repositories of all of the CPAN modules you're using, or all of the other open source projects you are using. Okay, so you have a list of dependencies. Okay, and you come here to metacpan.org, let's say, to this file, carp, and this is a bad example, specifically, let's say Apache lint, hopefully this one, this one maybe? Yeah, okay, so this one has a link to its repository. Okay, some don't, some have. And so now you have the link to the GitHub repository. So create a collection of them, a list of them, of the ones that you are using. Okay, and then slowly I improve the generator program that will take these ones and build a profile of languages you might use or issues that are open for each of these projects. Okay, so you will be able to have a look at them and say, okay, these are the modules I'm using. It has these and these and these have issues, and so I might contribute there. So that's it. And so see you next week.
Cool. Thank you very much.